Well, students, up to class 9, you have learned how to find the area of regular figures like squares, rectangles, circles, parallelogram, triangle, etc. Then in 10th class, you have learned to find the area of the combination of two figures like rectangle and semicircle, rectangle minus semicircle, like this. Now, what is the area of this combination? That is area of rectangle plus area of circle. And what is the area of this shaded portion? This is area of rectangle minus area of semicircles. Now, here we have to study to find the area of enclosed figure with the help of integration. Now, what is the meaning of enclosed figure? Now, let us consider a function a to b fx dx. Now, geometrical interpretation of this function. Now, geometrical interpretation of this function, that is area enclosed by the curves like y is equal to fx, x is equal to a, x is equal to b and x axis. So, this enclosed figure is geometrical interpretation of this figure. Now, let us consider that this figure, this enclosed figure is made of a large number of thin vertical strips. And now, let us consider a strip which is parallel to y axis and thickness of this strip is dx, because this strip is very thin and length of this strip is y. Now, what is the area of this strip? And the area of this strip is y dx. Now, y is length of this strip and this y is fx. So, what is the area of this closed figure? And that is, now this is a to b fx dx, and integration of this is fx limit from a to b, that is fb minus fa. Is it clear? Now, here the question is, find the area of the region bounded by the curve y square is equal to x, lines x is equal to 1, x is equal to 4 and x axis and x axis. Now, first figure is a parabola. This is a parabola whose vertex is at the origin at 0, 0 and symmetric about x axis, and this is symmetric about x axis. X is equal to 1 is a line parallel to y axis, x is equal to 4 is also a line parallel to y axis, and this is x axis. Now, area of the region, for finding the area of the region, let us consider a strip which is parallel to y axis and width of this strip is dx and length is y. Now, what is the area of this region? This is y dx, because upper end of the strip lies on the parabola. So, we have to take value of phi from the parabola. Lower end of the strip lies on the x-axis. So, no need of taking that value because on x-axis value of phi is 0 and x from 1 to 4. So, this is the area of bounded region. Now, we have to integrate this. Now, we have to write the value of phi from the parabola, and from parabola value of phi is under root x. Here we have to write the value of phi in the form of x. So, under root x dx from 1 to 4 under root x dx. Now, integration of this is x to the power 3 by 2, because this is x to the power half plus 1 is 3 by 2 and this is divided by 3 by 2 and limit is from 1 to 4. Now, if put the values of x, it becomes 4 to the power 3 by 2. Now, 3 by 2 upon 3 by 2 will become 2 by 3. 4 3 by to the power 3 by 2 minus 2 by 3 into 1 to the power 3 by 2 is nothing but 1. Now, what is 4 to the power 3 by 2? This is 8. So, this becomes 2 by 3 is common, 8 minus 1 and that is 2 by 3 into 7 and that is 14 by 3 square unit. Now, next question is, find the area of the region or area of the smaller part of the circle x square plus y square is equal to a square and the line x is equal to a root 2. Clear? Now, x square plus y square is equal to a square is a circle of radius a. So, coordinates of this point are a and 0 and x is equal to a root 2 is a line parallel to y axis. So, x coordinate of this point is a root 2. Now, area of the region, smaller part of the area of the region bounded by a circle and the strip is A, this point is B, C, D. So, this ABCD is the smaller part of the region bounded by line x is equal to a root 2 and the circle. So, this shaded portion is the area of the region bounded by smaller area bounded by circle and the line a upon root 2. Now, here y coordinate of this point, if we put x is equal to a upon root 2 in this, in the equation of circle, so y coordinates become a square minus a square by 2, that is a square by 2, y square is this. So, y is equal to a upon root 2. So, y coordinate of this point is also a upon root 2. Now, this area is area of A, B, C, D, A, but this area is symmetric about x-axis. So, it can be written as 2 times of area of A, B, C, A. Now, draw a strip which is parallel to y-axis. Of course, upper end of the strip lies on circle. So, we will put the value of y from the equation of circle and thickness of this strip is dx. Now, what is the value of x? X is limit is from a by root 2 to a. So, integration we have to find the area by the method of integration and this is 2 times. So, 2 times of a upon root 2 to a and y dx. Now, we have to write the value of y from equation of the circle. So, this is equal to a by root 2 to 2, a root 2 to a, y is a square minus x square under square root dx. Now, what is integration of this? We have learned in previous chapter that integration of a square minus x square is x by 2 under root a square minus x square plus a square by 2 sine inverse x upon a. Now, what is the limit of this? A upon root 2 to a. Now, we will put the value of x and find the area of the region. Now, put the value, this is 2 times x is a. So, a by 2, now under root a square minus a square, so it will become 0 plus a square by 2 sine inverse a by a minus a by root 2. So, this becomes a upon 2 root 2 a square minus a by root 2 square, that is a square by 2. So, it becomes a square by 2, a square minus a square by 2 under square root plus a square by 2 sine inverse a upon root 2 a. Now, this a cancel, this becomes 0, a square by 2, here also a cancel. So, this is a square by 2 sine inverse 1 is pi by 2. So, this is pi by 2 minus this is a upon 2 root 2, a square minus a square by 2 is a square by 2 and square root of that is a by root 2. So, this becomes a square upon 4 plus a square by 2 sine inverse 1 by root 2 is pi by 4. So, 2 into this value is 0, a square by 2 sine inverse 1 is pi by 2 minus a by 2 root 2 into a by root 2 minus a square by 2 sine inverse 1 by root 2 is pi by 4. Now, here a square by 4 is common. So, 2 into a square by 4, here we have pi minus 1 minus pi by 2. Now, this cancel. So, a square by 2 pi by 2 minus 1 square units. Next question is, find the area of the region bounded by the parabola y is equal to x square and the line y is equal to mod x. Now, this parabola y is equal to x square is upward parabola, its vertex is at the origin and y axis is its axis of symmetry. Y is equal to mod of x, these are lines, y is equal to x and y is equal to minus x, and these lines make an angle of 45 and 135 with positive direction of x axis. Now, here we have to find the area bounded by these lines and parabola. Since these shaded regions are symmetric about y axis, so we can write this as 2 times of area of this region. This point is A, B, C, D. So, this area of the bounded region can be written as 2 times of area of O, A, B, C, O. Now, these lines intersect the parabola at 1, 1 and this side at minus 1. Now, we will consider this part. Now, let us draw a strip. Here we have to find the point of intersection of two curves. Y is equal to x square and here y is equal to this side, y is equal to x. Now, put the value of y in the equation of parabola. So, it becomes x is equal to x square or x square minus x is equal to 0. If we take x common, x minus 1 is equal to 0, means either x is equal to 0 and x is equal to 1. X is equal to 0 and x is equal to 1. Means this line intersects the parabola at 2 points 0 and 1. Now, here y coordinate is 0, we know it. Now, what is y coordinate of that point? If we put x is equal to 1 here, then y is equal to 1. So, coordinates of the point B are 1, 1. Now, this shaded region, we have to find the area of the shaded region. This region is symmetric about y axis. So, this we can write 2 times of area of O, A, B, C, O. Now, draw a strip which is parallel to y axis and this is the strip which is parallel to y axis. And what is the length of this strip? This time upper end of the strip lies on the line and lower end on the parabola. So, here we have to write this as 2 times of y1 minus y2. Length of the strip is, if value of y on the line is y1 and value of y on the parabola is y2, then y1 minus y2 is the length of the strip and width of the strip is dx. So, this into dx, and what is the limit? It is from 0 to 1. So, this is integration of this from 0 to 1. Now, what is the value of y? y1 from the line. Here y is equal to x, line is y is equal to x, equation of the line is this. So, here this is 2 times of 0 to 1, value of y from the line